This is an update on my platform that I'm developing that's intended to be impervious, ultra secure, uh, completely guard data from dangers outside the application and within the organization where it'll be deployed. So, as I've mentioned in several videos before, many extant technologies will be leveraged, but I am doing a few ideas of my own. Those are, of course, TLS, which is the security uh, uh, means between within the network internet. It usually stops at the front door, so inside the organization where the app is served up, it's not going to help you a whole lot. And there's can be a lot of voyeurism by people who have access to the intranet once it gets past the gateway of the organization. And in terms of authentication, making sure each party knows who they're dealing with. TLS does it for the organization, but MFA will do it for the end user consumer. That's multi-factor authentication. They will send in a security code, i.e., password, but also the application will send out a one-time code that the end user will also have to provide. So it's instantaneous ephemeral password also that goes to say either an email address or a telephone number that proves that the person who's trying to log in will not only knows the security code but also still has access to the email account or the telephone number. Another useful thing that will be leveraged is password-based encryption, and that is where not only is a password checked to make sure it's the identity of the person, but it's even used as an encryption key. And that's a very useful thing that'll be mentioned later. Another thing is to go along with TLS is the ACME, and that's automated certificate management extension. And that's so that the software itself can be automated to go and get certificates that it will use to prove who it is. Sharding will be leveraged, and that's where you take a database and you split it up into several different databases. We'll keep track of sessions, load balancing by IP, since I will be using TLS all the way into the application. The data cannot be used to load balance because it is still encrypted all the way to the unit that's going to actually handle the request from the end user. And this platform, this landscape, is a lot like what you'd call VDI. Some providers call VDI, and that is the end user's view is just a view of a process that's going on inside of the server. And it's a little bit heavyweight, but it can be kept to a minimum. And there's good reasons for that. And then some other things that are developed are a servlet, special servlet. Since this is so unique, the servlet has to be special and by custom made. And by doing that, it will not suffer the vulnerabilities to using a generic servlet will subject an application to. In other words, this servlet that has been built won't respond to anything it doesn't expect. It just doesn't do anything. A technology that I appreciate and have always been a proponent of, but it's not that highly used, is Java server faces, and that is where the components that make up elements on a browser view are encoded in Java classes. So, like an input, a button, a table, etc., will be actually implemented in Java, and that's Java server faces. So, here's a description of how those things all play together in the landscape I've developed. I also put in JSON. That's not that important. But I developed some stuff with JSON. So end user will send in requests via TLS, and send back cert. With this landscape, I want TLS to go all the way to a worker unit that's going to handle the request. So that unit is going to firstly match up the data that's been submitted to JSF or Java components, and then inside the Java components, once it gets to the execution part of it, it'll go into a service layer, and that'll also be Java, and then you'll have a repository layer. But this will be TLS all the way to here, so you will have to leverage Java's TLS and not the stack of the computer. It'll be actual Java. So this is one big thing here. Also, something that's goes along with this is Java's encryption, and TLS uses that too. So I'll put TLS and Java here. So that comes with Java, and the request will come in here and be interpreted by the TLS infrastructure, and it's kept up to speed as TLS 1.3, and it's going to be as secure as possible. So a bunch of components were written to represent elements on a web page. The TLS will deconstruct the data, decrypt the data. The JSF will decode it into the elements, and then that will be passed on to a part of the application that acts upon that particular JSF's components concern, basically, and that'll be the service layers. So and this will need its own certificate for TLS to operate, so it'll have to use Acme. So an Acme interface has been implemented, and that'll go out to a certificate authority, get a certificate, and then that'll be kept in here. If this is to shut down and restart, it'll be stored in a shard of database encrypted. So it will be encrypted. It's not just an encryption key itself, but it can also be encrypted. And the way that will happen is, in order to start this worker, credentials will have to be added that are valid to start this and decrypt this certificate and any other data that this application needs to run. And the reason you use password-based encryption is so that the encryption key to such things is actually entered into the system from ahead of somebody starts it, basically. It's nowhere to be found. It has to be entered to start this and decrypt the pertinent information to run it. That's password-based encryption. Along with the Acme, in order to do Acme, a server has to be made, and so it's a lot like a servlet, but a server. But this serves up a web page on 80 to verify to the certificate authority that responds to the Acme. You can tell them that this website belongs to you. So that had to be made, and it's very lightweight. And in order to do MFA, something once a end user has submitted a credential, you also want to use a second version of authentication and send them an email or an SMS. SMS has not been implemented yet, but another chunk has, and that is running out of space here. But an email client. Well, it's not really a client, but it's an email server. But it's like the 80 server, web page server. It's also kind of a micro server. So when an Acme certificate authority goes to the regular verify the IP address here, some data will have to be sent back. That verifies that this unit has control over that IP address. And this email server, and so it's very small, it just sends a little piece of data back. This can be small also. This just interfaces with an email server of the end user's choosing, like Gmail server. So a person who signs up with a Gmail account will get a little email and says, if you're trying to log in, then use this number. That's MFA. So that's getting to be quite a kit there, but and that's what it would take to put to make an extremely secure web application server. And this will be a worker node, and it'll be able to be repeated multiple times. But in order to load balance between all of them, you'll have to use say IP address. And so this would be IP address 1 will get you here, and IP address 2 will get you here, and IP address 3 will get you to that one. You can't use data inside of the packet, so-called application data, because TLS goes all the way to the worker unit. So that's the server. Servlet server. Web service part of the application. Now, another crucial large part of this is the database, and that is where segmentation is implemented in the database so that person identifying information is not easily associated with business data. So what you do is keep business data in an area, and it can be multiple shards, but you can call it a shard, an area, whose associations have one key. So that's something you would know as like an account number. But this account number, no one will ever see, because it's internal, and it will relate this group of data to this login account in this identification, but I'll get to that in a minute. So anyway, so this could be transactions in an account or any other type of data, credit card transactions, etc., purchases, various things. But you'll have one number here that groups all of those to, say, one person. Could be one business, but one person. And then you'll have another database for, consider it an authentication, a person's logon, and that'll be another type of number. And probably have their credentials in here, so their username and their sort of their password, but username, maybe some find it key besides username. I guess password's not really going to be used in that way. But so in order to relate this person to this, you will not put this plain number in here. You put it in as a encrypted piece of information. So it has to be decrypted in order to associate this logon with that data. And this is personal data that somebody has entered. You could use the password-based encryption of an end user. But if it's business data, obviously other people need to get to it. So it will have to be decryptable by others. But it still will have to be decrypted in order to relate this to that, a person to that. And this is logon credentials, and that alone is not that useful information, although it is related to the business data. There'll be another area which is specific human identifiable information, PII they call it, or HIPAA, health information, etc. And that'll have multiple lines. It can be social security numbers, address, phone number, contact information, name, sex, etc. And that'll also have an association key, so you have a bunch of rows and they're all under one unique number. But just like the business data, that'll also be encrypted down here. So a scenario is a person will log on with PBE here. And they identify themselves by, say, a username, and then the authentication key, i.e. password they put in, will decrypt a crucial piece of information, but it'll also decrypt this to find their identity, and it'll decrypt this to find their business data. So kind of separated into three areas. And also, by separating these two, you can have multiple accounts, maybe for different reasons. But anyway, they will be connected by decryption of keys only. And then one other important step here is that all of this information will be encrypted. Not only the association key to other databases, but all of the pertinent information within each of those databases will be encrypted. And so a person having access to that database will not make heads or tails of the data as it sits there at rest, so-called at rest, while it's sitting on disk. Even if they're database administrators with 100% authority, they cannot look at that data and consider it useful for any kind of nefarious purposes. Yep. So And actually, that frees you up to let more people be DBAs without as much scrutiny of the background. And also, but another step would be to make separate by sharding this out into different areas. You can have a DBA here that is not the same as here, and so they won't put two and two together by some uh, ingenious means, ingenious but evil means. Uh, but when this DBA for this area looks at this, it'll serve very little purpose until it's decrypted, and it'll be decrypted by password-based encryption, either of the encryptor end user alone, or end user plus certain people who have been deemed appropriate for viewing the accounts there, that information. And all databases offer encryption, so the data on the disk is encrypted. It's just a big mishmash. When you look at it, you look at it as a file, but that's not what I'm talking about. You want people to have DBAs to have access, but they definitely, least privilege, they don't need to see names, house numbers, phone numbers, email addresses, stuff like that. They just need to see the general structure. It can all be the same structure, it's just those fields are encrypted so they can still do their job, etc. But how to get that encrypted inside it, like as I had shown in the worker node, you have Java encryption here. And so all of the communications to the database from here, from the worker node to the database, will only contain information that's been decrypted. So a lot of concern goes into how you secure data within the organization, going between the database and so-called microservices or services or macro services. This solves that problem in that this information is all encrypted. So you may still want to use TLS between these. I don't think it's necessary, but and when this worker node logs into the database, he will use some login information creds that will have been gleaned from the PBE of the person who was authorized to launch this app. So that'll be encrypted, it'll get into the database, etc. But most crucial point is that all of this data is encrypted anyway, and so there's no point in watching it. That means anybody who's managing all of the network equipment in there, having a look, is not going to see anything useful. If malware gets in there and is extant on the machines, it's not going to see a heck of a lot. The encryption keys are as constant in this worker node. They would have to scrutinize the memory, know how the program is organized, etc., 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 in order to get decryption keys and voyeur the data and decrypt it. It's a very, very difficult thing to do. Virtually impossible, hopefully impossible. But this is based upon my experiences in designing and how people design their intranets, their back ends, so called. This is an advancement, and it frees up the task of having to make this TLS back in here. So, but it does add the slight complexity of making TLS go all the way to the worker node, and multi-worker nodes are going to have to suffer some extra overhead management. And of course, encrypting everything adds some difficulty in bandwidth of the CPUs. So buy NVIDIA stock, but it also is going to have add a little bit of complexity in database searches and indexing, but that can be got around with good uh, one-way encryption, where you'll create trees with digests and good search schemes with the digest of the information. And it was in the 90s, it was brought up that all connections to a database should be connectionless. There should be no information left on the server whatsoever after the end of, say, a search or update of a cart or whatever. Everything should be on the client. They should have some piece of information that could reboot the worker and tell it all about it. And that's largely implemented. The motive for JWTs implemented JWTs, uh, but I've chosen to have a, a worker node keep track and have a long running session, and almost basically VDI, where you actually have running code for you on the server, because that's going to be more secure, and it'll also be more quicker to respond to a request from an end user, and it's more secure because don't want to put too much information in the JWTs. Just sort of a reference to a reference and a track keeper, basically a track keeper that says this JWT is from the end user. It's in a good sequence that means that it hasn't been stolen, and there's no hijacker out there trying to reuse some old piece of information he found in on a machine somewhere. So that's what the JWT is for, but also have this running uh, continuously for a little while until the session times out. If an end user leaves for 5 minutes, then a session should probably time out, and so this will record that a session should go away, and they'll make them end user sign in again. So that is the state of the landscape. That's all been done and up and running. And I have a application running on this landscape also, with interesting business data, and that'll have to be presented later. But this is the landscape.